Hey guys, here's your guys' lecture video on complex numbers division. So today we learned students will be able to divide complex numbers by using the conjugate. Now the definition of a complex conjugate is the complex conjugate of a plus bi is a minus bi. So when we take a look at these examples, first you guys have to write down the conjugate. So as you guys can see from the definition, complex number is a plus bi, the conjugate of that is a minus bi. So the only thing that changes is the middle sign between the two terms. So since this is 5 plus 2i, the conjugate of this, you guys, is 5. The opposite of this, minus 2i. If you guys did this one, the conjugate of 3 minus I is the opposite of this sign. 3 plus I, and that's the conjugate. And for part C, the conjugate of this is the opposite of the middle. Negative 2 plus 4i. Now, as you guys can see from this problem, we have to multiply these. And this is where I told you guys gotta do your double distribution. So 5 times 5 is 25. 5 times negative 2i is negative 10i. 2i times 5, now we're on the red, right? 2i times 5 is 10i. And 2i times negative 2i, you guys, is negative 4i to the second power. Now, the I to the second power, you guys, this is negative 1. I to the second power is negative 1. So I'm going to rewrite this. 25 minus 10i plus 10i. Now we have negative 4 times negative 1. And negative 4 times negative 1 is positive 4. Those cancel, so all you guys are left with is 29. Okay, let's do B. Again, we distribute both of these. 3 plus 3 times 3 is 9. 3 times I, 3i. Negative I times 3, we are here, negative I times 3, using the red pathway, negative 3i. And negative I times I, negative I to the second power. So now, we know I to the second, you guys, that's negative 1. So now we have 9 plus 3i minus 3i. A negative times a negative 1 is a positive 1. Cancel, and we just have 9 plus 1, which is 10. So there is something you guys should be noticing. There is something you guys should be noticing when you guys are multiplying by the conjugate. Just keep that in mind. Negative 2 times negative 2 is positive 4. Negative 2 times 4i, negative 8i. Negative 4i times negative 2 plus 8i. And negative 4i times 4i is negative 16i to the second power. But I to the second power, you guys, that's negative 1. So I'm going to rewrite everything, just dropping it down. But negative 16 times negative 1, that is positive 16. Cancel, and we just have 4 plus 16, which is 20. Now, let's answer this question. What do you realize when you multiply by the conjugate for each problem above? Well, we multiplied those were conjugates of each other, those were conjugates of each other, and those were. So the thing you guys should notice is the imaginary numbers cancel. Look, all the imaginary numbers are cancel, and all you guys are left with is real numbers. So imaginary numbers cancel, and you get a real number. This happens all the time. When you guys multiply a complex number by its conjugate. So, complex numbers, you cannot have an imaginary number in the denominator, which is huge when we go over division. So, you multiply the numerator and denominator by the complex conjugate. You simplify the expressions in the numerator and denominator, simplify the fraction if necessary, and you split the fraction so that it is a standard form a plus bi, if necessary. So, for part A, follow the steps, right? So, what is the conjugate of this denominator? The conjugate of that denominator, you guys, is 3 plus I. And follow the steps, right? Multiply the numerator and denominator by the complex conjugate, which is 3 plus I over 3 plus I. So then, we gotta distribute. But then in the denominator, you guys, one thing you guys should notice is we only get real numbers, right? And we'll take a look at this one. So since you guys know you only get real numbers and the imaginary numbers disappear, what you're really doing, and this is a shortcut, you're really multiplying the two numbers, the front numbers, and you guys are multiplying the two second numbers. And if we strictly just multiply those, what do we get? Well, 5 times 5, you guys, the blues, right, is 25. And 2i times negative 2i is negative 4i to the second power. And I to the second power, you guys, is negative 1. So what we really have is 25 plus 4, which is 29. And look, that's what we got, right? So we don't have to do a double distribution for complex conjugates because we know the middle terms, the imaginary numbers, are going to cancel. So we're going to use that same shortcut here. This only happens if we have complex conjugates getting multiplied together. Multiply the first two, and we multiply the second two. So the purple, 5 times 3 is 15. 5 times I is 5i. 2i times 3 is 6i. 2i times I is 2i to the second power. Now we got the blues, right? 3 times 3, you guys, that's 9. Negative I times I is negative I to the second power. Both I to the second powers become negative 1, because that's literally what I to the second equals to. It's equals to negative 1. So now let's rewrite all this. 15 plus 5i plus 6i. 2 times negative 1 is negative 2. 9. A negative times a negative 1 is a positive 1. And then we just combine like terms. These are your real numbers, you guys. And here's your guys' imaginary, right? So 15 minus 2, because we want the real numbers at first. That's 13. 5i plus 6i, 11i. 9 plus 1, 10. So we want it to be in the a plus bi form, you guys, standard form. So to make this look like standard form, we're going to split the fraction. 13 over 10 plus 11 over 10i. And there's your guys' final answer. So again, just follow these notes, right? These notes help you guys to solve and to guide you how to do each one. Part B. What is the complex conjugate of the denominator? The complex conjugate of the denominator, you guys, is negative 1 plus 6i. So we multiply the complex conjugate to top and bottom. So now we're going to do a double distribution. And then the shortcut, because remember, when we multiply the conjugate to a complex number, the middle terms will cancel. So we multiply those together and these together. Okay, the purple. 2 times -1 is -2. 2 times 6i is 12i. Now we're on the red. Distribute, right? I times -1 is I times 6i, 6i to the second power. Now for the denominator, we're going to do the shortcut, right? -1 times -1 is 1. -6i times 6i, you guys, that's -36 I to the second power. And let me color coordinate it for you guys, so you can clearly see where I'm getting each part. Now we just gotta simplify, but before we do that, remember the I to the second, you guys, that's really -1. So we get -2 plus 12i minus I. 6 times -1 is -6. -36 times -1, you guys, is +36. Now we simplify. Here is our real numbers. Here is imaginary. So -8 plus 11i all over 37. Again, we want it to be in standard form. So this is going to be -8 over 37 plus 11 over 37i. And there's your guys' final answer for that. Okay, for part C, last one. Multiply top and bottom by the conjugate of the denominator. The conjugate is 4 minus 2i. And now we do a double distribution on the top. And on the bottom, since we're multiplying by the conjugates, you guys, we can do the shortcut. 4 times 4 and 2i times -2i. Okay, purples. -9 times 4 is -36. -9 times -2i, that's +18i. Now the reds. -4i times 4 is -16i, and -4i times -2i is +8i to the second power. The bottom, 4 times 4 is 16, and 2i times -2i is -4i to the second power. Now recall, you guys, the I to the second powers, those are really just -1. And now you guys just simplify, or let's copy down everything. Just drop them down. Okay, 8 times -1, that's -8. -4 times -1, you guys, that's +4. So on the bottom, we're going to have 16 plus 4. So we're going to combine like terms. These are the reals. These are the imaginaries. So we got -44 plus 2i all over 20. And we're going to split them up because we want it to look like standard form. And the last piece for this, you guys, is we gotta simplify the fraction. Divide this one by 4 to top and bottom, and this one by 2 to top and bottom. So you guys get -11 over 5 plus 1 over 10i. And there's your guys' lesson on complex numbers with division. Okay, so again, do your best to try to understand this, and then try out the homework to get more practice on it. Okay, good luck, you guys. Peace.